Hello everyone, my colleague is Fanny Lachery and she is PhD student in archaeoenvironment at Paris-Sorbonne University. And my name is Jonhattan Vidal. I'm an archaeologist at the French Ministry of Culture. We are pursuing this world tour, bringing you now in the Southern Hemisphere, in the Indian Ocean, and we want to present how we visualize micro-relief in a macro-relief landscape in Mafate at La Réunion Island.
We're going to. Okay, thank you. So yes, first we'd like to present you Vidal Island because there's a lot of chance we don't know what it is, what it is. So this is a French island situated in the Indian Ocean, just right next to Madagascar. This is part of the Lachery archipelago, maybe even Mauritius Island, better than Vidal Island. This is just neighbor islands. The Vidal Island is from volcanic formation and is only 3 million years ago. And there are two main volcanoes, the Piton des Neiges, the snow peak, and the Piton de la Fournaise, the furnace peak, which is still today. So there are regular eruptions. This is a rather small island with 2,500 kilometers squared, so 80 times smaller than Great Britain, so very small island. This is an island situated on the tropics, so we have a tropical climate with really, really heavy rains during the summers. The topography of the island is quite characteristic because the two volcanoes we just talked about are like two cones merged together. Yes, and so, sorry, the island is almost conical in shape, with highest point at 3,000 meters high. So this is a really tiny, really high island. So volcanism, earthquakes, and erosion led to Piton des Neiges dismantling for millennia and resulted in the formation of research that you can see here. So this is the cirque of Silos, Salazie, and Mafate, and we are just interested in Mafate today. Each of these cirques is also a draining basin where erosion is really, really, really intense, and that's it. I'm so sorry. Mafate, so one of these cirques, can be considered as an island of its own inside La Réunion. This proportionally small cirque of only 100 kilometers square is home to a wide variety of landscapes, as you can see there. The specificity of Mafate is that there is no road to Mafate and no road inside of Mafate. So the people living there just walk. There are only hiking path, and this is almost 800 people living there, so not really 200 people. About the history, Vidal Island is only about colonial and contemporary archaeology because it is a desert island until 1663. Mafate Island can be just seen as 3 big blocks. Usually, during the 18th century, this is the Marronage time, where slaves fled and hid in the center of the island. During the 19th century, poor farmers started to settle in this height because they were just unable to afford a living in the seashore. So they tried their luck in the heights. And after slavery abolition, in 1938, we can see sanitary tourism thriving for a few years as a thermal spring was used to cure like almost everything at the time. From an archaeological point of view now, we only have a few data. Some prospections were done between 2008 and 2011, and 3 sites were linked to this poor farmers' activity, while 8 sites with high archaeological potential were detected. As we just saw, we only have a few archaeological evidences in Mafate, and prospection were always conducted in hope to find this slave stump site. 3 reasons explain why. The legends there are more numerous than the facts in this area, and are used to face the difficult history of slavery. The subject is also highly political since a few years, and historical studies are usually biased to supply this vision. So history and archaeology in Mafate are then expected to be about this topic, even if there is so much more to know about. Another problem to studying the sage is its nature, making classical method of research hard to put in place, and Jonhattan is going to explain.
To us, this study had several goals. Study Mafate history and archaeology with new eyes through a diachronic and multi-thematic approach, find a way to discover sites with only a few historical clues, and find a way to be effective in this kind of landscape with tropical vegetation and this topography, and working with other specialists to further understand discovered sites. In 2014, Réunion Archaeological State Office ordered a laser scanning survey of Mafate Cirque, but never exploited it. In 2019, we started to use this tool to explore its capacity to detect ancient human settlements and activities, and launched a research program in Mafate. DTM had during this program a main role since each scientific domain and studies were organized through its analysis. As this video shows, Mafate is truly a difficult area to study because of its topography. No archaeological project this complete could have been done without the help of the LiDAR survey. It's a real mountain landscape. LiDAR acquisition was done by helicopter on the entire cirque with a density of 80 points by meter square and 11 points by meter square touching the ground. This result is quite good given the context where there is a tropical vegetation which is never dead even in the winter. The resulting DTM has a resolution of 50 centimeters, which allows us to already spot a lot of features. This detection is made possible at SERP scale to detect large archaeological ensembles or favorable settling topography by visualizing our DTM with PCA analysis of hillshade, with local relief model overlay on slope, and visualization of archaeological terrain. At site scale, we usually switch to other analysis to detect fine features such as scale factor, open topography, and point cloud checking. This last one is also an interesting tool to already have an idea of the real state of each site in terms of vegetation, and can be used to interpret vegetation repartition before visiting the site. In some cases, it can help to detect and identify trees of interest. Here are some of the main features we have found in Mafate during our project. Circular enclosures are very frequent in our sites and are oftentimes built joined to a massive rock that can be moved and is then used as part of the structure. What is this one? And the enclosure around. Retaining walls are almost everywhere since slopes need management to receive structures. They can be as high as 2 meters or as low as 20 centimeters. Walls exist mainly as land limits and are always made in dry stone. And a lot of paths can be seen in our DTM and help us to understand connections between areas. On a few occasions, we found stone extraction sites or drains to manage rainfall or to irrigate cultures. An important part of our data processing is about DTM features digitization. We elaborate a simple way to digitize and classify features. We first need to represent features in form of a surface or line based on its real geometry and size, and describe its nature, if it's positive, negative, shouldering, or ledge signal. Each feature is then described in form for asking for the source of information, its type, and if it's seen on the field or not. After this technical interpretation, we follow up with the technical is this one, and the archaeological interpretation on another page, to assume our structure identification, its chronology, and the accuracy of our guess. Our work presents for each group of entities this synthesis of visualization and interpretation with the different visualization and the notation of the structures. In the end, all these digitized features create an archaeological map at Mafate scale, where each feature is located and shown by relief tip or archaeological use. Today, we digitized more than 4,000 features in every part of the survey. Plans of each site is also created this way by checking on field or first guesses and refining structure geometry. Our GTM is precise enough to skip usual fieldwork such as structure planning and allow us to be even more efficient in our pedestrian prospections, where we can't bring a lot of material since we have to carry it by ourselves on difficult paths and off-road. Now back to Mafate to share with you some of our results. As Fanny explained you, Mafate is a hard-to-reach place, and we count some Réunion Park national agents as team members. On field, we have to ensure security of everyone, and DTM is in this way very important to spot safe accesses to our sites and to detect no-go zones where ground might have been too unstable. Rapidly, our fieldwork consists in finding features seen on the DTM, clearing them from the plant, recording them with our real-time GPS, and by picture. A floristic survey and artifact research are also conducted to better understand each site, and the use of 1950 aerial photographies is also a great help to understand the recent history of our sites. This multi-proxy approach is at the core of our study as we opened our research to other scientific domains.
After this fieldwork, we identified several archaeological site types. Here we are showing only 3 of them. First, there are the isolated habitats in austere areas, such as St. Susan River. In this steep-sided valley where no one lives anymore, we have found several structures perched on slopes. They consist of 2 to 3 houses on each plateau in the middle of the slope, while on lower plateau, we only found agricultural remains. So this is the river, the lower plateau, the middle plateau, and there are upper plateau. These complexes shown a lot of artifacts that allowed us to date our site from early 19th to mid-20th century, and even some decorative plants arranged in gardens that are still alive. Connections exist between these lower, middle, and also upper plateau. You can see a path just right here. And all of the 3 complexes are interconnected. The upper plateau were impossible to reach, but we think they might have been used as entrance area. Here you can see one of the little house rendered in 3D after photogrammetry. You can see another one here. So these houses are the best preserved structures of Mafate. They are stone base where wood poles are still in place and prove there was wood walls over. About the artifacts, you can see a bottle. We found like hundreds of pharmaceutical bottles, we don't know why, and a lot of daily objects, such as this lighter. Another interesting site is Boisjon House, which we detected thanks to a big earthwork. You can see right here. Once on site, we discovered an area completely man-made, with 2 terraces, retaining walls and stairs. There was no artifact. We don't know how to date this place, maybe 19th century, and we guess there was a single house on the top of this terrace. So yes, something really invisible. The LiDAR DTM showed this, so we trust it. We also trust Jonhattan, and it was really worth it because when we cleared the plans, we just found really impressive walls. Another type of site is an abandoned plateau facing erosion. As you can see, all of the plateau is vastly man-made, once again. It is a vast agricultural area, and we have found some structures with a chapel and a cemetery. It was all abandoned because of erosion and flooding, according to archives and geological expertise. DTM shows an area modeled by geological phenomenon, and what's interesting to note is that on this site, everything is just going down the river because of erosion. This is destructive. This is destructing the structures. And on this side, byproduct of erosion are just covering the remaining structures. So this is a site that was abandoned because of erosion, and now the structures are threatened by erosion. So the DTM, some of the structures, and this feature is actually the chapel. A subject we were really interested about is Mafate thermal activity. This history was a little bit known, but the localization of the site was really unclear. So the first step was to locate the thermal village, thanks to DTM. So this is the upper village. There is a lower village that was destroyed, or at least covered by the new riverbed. Once on site, we have a really dense, really dense fieldwork to find and study this village and also the thermal springs. We improve historical knowledge of this place by digging into archives, but also by exploring geological environment near the thermal station with the use of LiDAR datasets and a thermal imagery. Okay. Here you can see some of the structure we have found, so terraces, retaining walls, and houses bases. We had the chance to have so much archives and iconography on the sites to better understand the history. And we also put some extra effort to take the same pictures as our ethnography, and it's really interesting to see what an economic and touristic center of Mafate in the second half of the 19th century looks like today.
Well, this short review with this short review shown you a few examples of our sites, and after the exploration of 10 test zones in the cirque, we can define a typology of sites, this typology of site is linked to slope categories. We now have a good idea of type of habitats and activities through the ages in Mafate. It constitutes now a material point of view of Mafate history, more tangible and diverse. The cirque today, viewed as a haven for trekking and nature traveling, is frequently considered as a real wide and natural space. Our research and these integrated approaches allow to understand this place as a cultural landscape where we can read the human past, find archaeological evidences, and study relations between human activities and their environment through interactions and developments. After these archaeological considerations, we would like to talk about more of a technical subject. Exploring Mafate DTM with such a wide range of altitudes, we often remark an atypical signal. We call it confetti because of this appearance and the VAT. And it consists in an assembly of a very contrasted and colorful pixels neighboring each other. And we quickly saw that these opposite values are located in steep cliffs or at their base. To understand the signal, we checked the point cloud and identified its cause. This happened when several classified ground points next to each other have the very distinct altitudes. And this results in peaks in our DTN. So, as you can see, the DTN show a lot of peaks, and with the point cloud, we can understand that this place are cavity and overhanging rocks can be seen. And this signal is, can be used as a tool to detect this kind of morphology and show us places with an archaeological interest, because we know elsewhere in the island some sites in this context using geological entities as rock shelters.
Okay, and this, to conclude, the project is far from being over, and we have to start again in 2025 with this competitive phase. Thank you.
Thank you.